Okay, as promised, here are the evens to chapter 11, lesson 4. So let's just start. I'm going to start with 22. Hopefully you didn't have problems before then. So 22, we have a right triangle. And I'm just going to sketch these right triangles. It's just a lot faster if I just do it by hand, even though they're going to look awful. Okay, that is really awful. It wouldn't be faster to do this. Let's see, on this particular one, on 22, I think I can use a figure here. There we go. That looks much better. Okay, and I'm going to fill in what they give us. They give us x here and 12. And they give us that the angle measurement is 25, and we're supposed to find x. Now remember, this is a section on tangents. Later they're all going to be mixed up, and you're going to need to know whether you use sines, cosine, or tangents. This one we're given an angle, and we're given the side opposite, and we're given the side adjacent. So if you remember this from class, SOHCAHTOA, whoops, that's SOHCAHTOA, if we're given, this one across here is the opposite, the one beside it's adjacent. So we're given the opposite and the adjacent, so that means we're going to use the tangent. Tangent is equal to opposite over adjacent. So we're going to figure out, so we know to use tangent, so we would say tangent. Remember, we know to use tangent because we have the opposite and adjacent. For you guys that didn't have trig, it's tough. So tangent of 25, because tangent is of the angle, is the opposite, which is x, over the adjacent, which is 12. So then when we do this, we would just cross multiply there. We would put the tangent of 25 into our calculator, which I didn't do ahead of time. Should have done that. 22. So when we put that in. Let me just put that in real quick. Sorry about that. 25 tangent. I get 0.466 equals x over 12. Now we cross multiply, which means we're going to multiply that times 12. I just left that number in my calculator and multiplied it. And I get x equals 5.6, basically. That's what the book says. The answer book says 5.6. So that means this side x right here is 5.6. Let's try another one real quick here. 24. This triangle is a right triangle that's kind of flipped around. Let me see if I can do that. So we have the right triangle. Let's see if I can flip it around. I'm not that good with this program yet. I can't really flip it around too well. So I'm just going to draw it. So we have the right angle at the top this time. And here's our right angle. And it's connected here. This is our right angle. You can use your imagination. This is x, 14, and the angle that they give us is 35. So we're always working with whatever angle they're giving us. So when you're trying to figure out if you're dealing with opposite or adjacent, you start with this. It's opposite the one that's given, or adjacent to the angle that's given. So we're given the opposite one, and we're given the adjacent one. This one here is a hypotenuse. We're not given anything about that. So when we go up here to SOHCAHTOA, we don't want to use the ones with hypotenuse because they don't give us anything about the hypotenuse. Remember, the hypotenuse is opposite the right angle. So we would use tangent because we have, this is a tangent chapter, set lesson. And we also have, here's our angle, we have the one opposite and the one adjacent. So we would say tangent of 35 equals the opposite. So this is the opposite, will be 14 over the adjacent, which is the one right beside it that's not the hypotenuse, over x. So in our calculators, we put 35 tangent, and I got 0.7. Let me just make sure I got that right. 35 tangent, yes, I got 0.7. And times equals 14 over x. We cross multiply. Whoops, should be an x. So we have 0.7x equals 14. And we will get x equals 20. You want to make sure it makes sense. If you get a negative number, you know side can't be negative. And 20 seems reasonable, but I'm going to check it in the book anyway. This is number 24. They got 20 as well. So that answers 20. Let's try to get one more on this little part. 26. You can fast forward. If you got some of these right, just fast forward till you get to the ones where you've got stuck. 26 is different, though. You need to really pay attention to the difference. 22 and 24, we were trying to find a missing side. When we hit 26 and 28, we're trying to find a missing angle. So let's try 26. I think I can do a triangle thing with that. Please the right direction for me. There we go. So in this one, the right triangle, this one we're given that this side is 25. They're giving us the sides this time. They're not giving us the hypotenuse. They don't give us the hypotenuse when they're doing tangents. This is 21. This is our right angle. They want us to find this angle right up here. So note, these two, you're finding sides. So you use tangent. When we're trying to find the angle, we're going to use the inverse tangent. So we're dealing with this angle, so we would say the tangent of x, we start out with the tangent, equals opposite, which is 21, over adjacent, which is 25. We would say the tangent of x, and then in your calculator, divide 21 divided by 25. Which I'm doing. 21 divided by 25 is 0.84. The thing is, we don't want x. We want the tangent of x. We don't want the tangent of x. We want x. So we need to get x alone. So what we're going to do is we're going to say x equals the tangent. It's kind of like dividing both sides by the tangent. The inverse tangent of 85 will give us the angle. So with the angles, we're going to end up using the inverse tangent of the ratio between the opposite over the adjacent. So then we just put that in our calculator, and I get the angle is 40 degrees. I think I did this in class. So this one you're going to do the inverse tangent. Let's move on to 28, which should be about the same thing here. 28. Let's write our SOHCAHTOA up here so we don't forget. S-O-H, so, ka, toa. Okay, 28. Here we go. We have this one right triangle that I can't do with my triangle maker. So here we go. Our right triangle right here. We have sides. Remember, if you have sides, we're going to use the inverse tangent. If we're looking for a side, we're going to use the tangent. This time we're looking for an angle, so we're going to end up using the inverse tangent. It's going to be the inverse tangent of the ratio of opposite over adjacent. So we can say the tangent of x equals the opposite, which is 45, over 26, and we'll put that in our calculator. 45 divided by 26 is 1.7307. I just keep that number in my calculator. And then I'm going to take the inverse tangent of that number. So we're going to get x equals the inverse tangent of this number, which I'll have in my calculator so it'll be more accurate. It has more digits out. So I'm going to do inverse tangent, and I get 59.98, etc. And I'm just going to round that to 60 degrees. So that's how you get those using inverse tangent. Of course, in the book for 28, they have 30. Let's see, what did I do wrong? Let me see, tangent of 15. Oops, did I copy the wrong numbers? Oh, I did. I couldn't read my own writing. So this should have been 15 over 26, but you would do it the same way. Now my one looked like a 45 there for me. I should have known by looking at that picture. So the angle when I did it was 60 degrees, but you would have 15 over 26, you get a different decimal. You should have got, it doesn't matter because you're not doing these anyway, but for this one, you should have got I should have got 1.429. And then when I did the inverse tangent of that, I would have got, for that number, I would have got 30 degrees. Okay, let's move on to set number 2. Let's try 30. 30, they start making these word problems. They're trying to make them more practical. So 30 says, find the distance from the bottom of the ladder to the bottom of the well, given that, let me just draw this, which I can, because my triangle goes the right way. Yay. Okay, here's my triangle, and we have A, B, C. You don't even need to know all the information if they give you the word. So here they give us X, 50, and 16. Okay, we're trying to find the side, so we're going to use tangent, not inverse tangent. Remember, when we're trying to find the angle, we use the inverse tangent. So they want us to find X. You can skip all the words. It says AB is 16, and they give you the picture. This angle is 50. They're just showing you the ladder goes right here. So you're going to say the tangent of 50 equals the opposite of 50, which is 16, over the adjacent to 50, which is X. And you just plop tangent of 50 into your calculator, and you get 1.192, if I round it, equals 16x. So you get 1.192 times x equals 16, and then I'm going to divide both sides by 1.192. So 16 divided by 1.192, and I get 13.42 feet. They actually round this to 13 feet. If there's feet or units in your problem, you have to have units in your answer or else it's going to be wrong. Okay, let's try, let's do 32. Oh, hold on a second. Need a whole new page here. Okay, 32. 32 is similar to 30. Except I do believe in 32 you have to find an angle. So we have the same triangle that I can do with my triangle maker. We have a triangle. This time they're giving us, this side is 48 feet. Write that in meter. And this is 103 feet. This is a right triangle, and this is X. The problem says find the angle of elevation of the top of the movie screen as viewed from the point C. This is C. Given that AB, let's put A up here. AB is 48 feet. So they want this angle. You can see it. So they want an angle, so we know we're going to use eventually the inverse tangent. So we would say tangent of X equals opposite over adjacent. And we would have tangent of X. If we divided that and rounded it a little bit, we're going to get 0.46. And we take the inverse tangent of both sides. And so we'd get inverse tangent for X equals inverse tangent, that's how you write inverse tangent, for 46. And we would get the inverse tangent, if we put that in our calculator, we would get 25 degrees. Put degrees because it's angles are measured in degrees. If your calculator isn't giving you this, check to make sure that you have it in degrees. Sometimes your calculator can be put into radians. And if you're not getting the right answer, it's because you need to switch your mode. So hopefully you can get someone to help you switch your mode, or I'll help you when you come to class, or just get some cheapo calculator in your drawer and put that other one away for now. Alright, 34 is a proof. I'm just going to talk you through the proof instead of writing the whole thing out. We have a right triangle. Oh, very bad right triangle. I wish I had some sort of tool to help me write a right triangle with the right angle right there. So the right triangle FRU, FRU, and you also have an altitude right here, and this is a 1, so 1 there, and you're given a right triangle FUR with altitude RO. You're supposed to prove that the tangent of 1 equals the tangent of U. When you're doing the formal proof, you would write your given, that you have a right triangle and that you have an altitude. Then you would say, for this, since it all have to be in your proof before you start, you'd have to say RU is perpendicular. Oops, am I doing 33? You would have to say RO is perpendicular to FU, because a line segment is an altitude if it's perpendicular to the line opposite. If and only if it's a segment from a vertex perpendicular to the line opposite. Then we'd have to say that ROU and ROF are right angles. So now we have 3 right triangles. We have the little one, the bigger one, and the biggest one. So I would start, after you get all that these are their right angles because you have an altitude, you can say FOR is a right triangle, ROU is a right triangle, because if a triangle has a right angle, it's a right triangle. Then I would jump right into here. I would say the tangent of 1 equals, it's opposite, so it's FO, over the adjacent angle, would be this one right here, RO. That doesn't look like an O, does it? It looks like a D. I'm going to confuse myself again. This side right here is the hypotenuse. So make sure you don't just do opposite over this one. This is the hypotenuse of the triangle, so opposite over adjacent. And we know that the tangent of U, there's 2 different things you could put. You could either make U the angle in the big triangle or U the angle in the small triangle. Actually, if there were numbers in there, they would be the same. Angle was not going to change. But we're using the small triangle. The tangent of U equals opposite, so that would be RO, over the adjacent, which would be OU. So we just took the information that we were given, and we know we need to get to tangent. We're kind of working from the answer backwards. And then we're going to apply the altitude to the hypotenuse of a right triangle is the geometric mean between the segments into which it divides the hypotenuse. That's one thing you can use, or else you could use the altitude forms similar triangles. They both work in proving this. The first time I did it, I just did that this triangle is similar to this triangle, so I did the sides were proportional, and eventually I was able to do this proof. Let's just do the one that says the altitude is the geometric mean between the legs in a right triangle. So because that's true, we can make 2 fractions. The altitude is the geometric mean, so it's going to go here and here. And the legs would be FO. The altitude, if I write, is the geometric mean between the segments in which divides the hypotenuse. I said that wrong. So it's going to be FO and OU. And if you look, here's FORO and here's ROUO. So by substitution, we can say the tangent of 1 equals the tangent of U. So you have to remember all these things, like how they divide. It's kind of complicated because in the last one we had that side splitter theorem and we had the angle bisector theorem. So keep these all fresh in your mind. I would look over them and try to remember them. Okay, that's it for the evens for lesson 4.